Final key features, then the graph. So here we have vertex form. Let's begin with the concavity. The concavity is determined by the a value. Here we have a negative a, so this is going to be concave down. For the y-intercept, we have to evaluate the function at 0. So we're going to replace all of our x's with zeros, and then we're going to calculate. So here we get negative 2. Quantity, 0 minus 1 is negative 1 squared plus 10. And then negative 1 to the second power. That's going to be positive 1. So we get negative 2 multiplied with 1 plus 10. Negative 2 times 1 is negative 2. And then if we add 10, we're going to be left with 8. So here is my work for the y-intercept. So the y-intercept is going to be at 0, 8. Now I'm going to do the work for the x-intercepts in green. To get the x-intercepts, we're now going to set the function equal to 0. So here we're going to solve negative 2 x minus 1 squared plus 10 equal to 0. And to solve this equation, we're going to begin by moving the constant to the other side. So we're going to subtract 10 from both sides. And then on the left-hand side, the 10s are going to cancel out. And we're going to be left with negative 2 x minus 1 squared. 0 minus 10 is negative 10. Next, we're going to divide both sides by the coefficient of negative 2. On the left-hand side, the negative 2's are going to cancel out, leaving us with x minus 1 quantity squared. And on the right-hand side, negative 10 divided by negative 2 is going to be positive 5. And if we want to if we want to get rid of the square, we got to take the square root of both sides. On the left, the square and the square root cancel out, leaving us with x minus 1. And on the right-hand side, we get plus or minus root 5, since 5 doesn't have a perfect square, and we cannot simplify the radical expression. So next, we're going to add 1 to isolate x, and we're left with x equal to 1 plus or minus root 5. Now, this is the exact solution, but since our goal is to eventually graph this, I'm going to go ahead and use a calculator to approximate both of these values. And using the calculator, I'm getting the approximation of about 3.2 and negative 1.2. So my x-intercepts are going to be 3.20 and negative 1.20. Now, to get the axis of symmetry, since we have vertex form, we can just look at the opposite of our h value. So the opposite of negative 1 is going to be positive 1. So the axis of symmetry is going to be x equal to 1. And to get the vertex, we're going to pair the axis of symmetry with the k value. Here that's positive 10. So the vertex is 1, 10. Now, because we had a parabola that was concave down, notice that it's going to have a maximum. So the vertex is a max. Now that we have all the key features, we can go ahead and graph. Transitioning to the graphing component, I'm going to begin by plotting the vertex at 110. And next, I'm going to draw the axis of symmetry, the line of reflection that's going to cut through the vertex. This is going to help me reflect the y-intercept. Once I have the axis of symmetry, I'm going to go ahead and plot the y-intercept, which is at 0, 8. And now notice that the y-intercept is one distance away from the axis of symmetry. So I'm going to go over one distance over, landing on the point 2, 8. And then finally, I'm going to go ahead and graph the x-intercepts. I'm going to use my best judgment to approximate these on the x-axis, beginning with negative 1.2. Some here on the left, somewhere here. And then I'm going to plot the 3.20. So 3.2 somewhere around here on the right. And now that I have all of the key features, I'm going to connect the points with a curve. And this should give me a sketch of the parabola.